meeting is being recorded. Okay, we've just started recording that. So the first question in this was, suppose P and Q are statements that can evaluate to true or false. What does supposing, I hope you guys have opened that on your end. I can't really open on my laptop. Looks like or seems like there are processes running in the background which I can't seem to find. Okay, so suppose that's question 1. Suppose P and Q are statements that can evaluate to true or false. Let's see. This is written as what? CSC 2901. Let's see. CSC 2901. Nothing. Okay. Only 2022. Okay. So suppose P and Q are statements that can evaluate to true or false. A, what does the implication P implies Q mean? What does the implication P implies Q mean? Okay. Can you hear me? Erica, can you hear me?
Yes.
Is screen visible?
Yeah.
It is not. That's quite bad. Maybe can you open the solution sheet on your end? And if anything, you have a spare gadget, you also open the paper. I think that would be quite helpful. Okay, thank you. Right. So, what does the implication P implies Q mean? Remember, we can't overemphasize. Marks allocation is very important, and that's 4 marks. Quite there. So you need to put as many statements as you can to basically obtain those marks. So if you see at first is P implies Q, what does it mean? So you need to define those. So by definition, P is implication and Q is conclusion. That is very important. Comma, if P, then Q. That's what that means. Okay, when you see the one on top, P, 2 equal sign there, plus arrow Q, then you say, okay, P equals then arrow Q, then arrow Q means if P is true, automatically Q is also true. So marks allocation there is quite important. I think we can't overemphasize that. Okay, We really can't overemphasize that as you go in that test of yours. Very, very important. If you need those A's, you need those A pluses, B's, B pluses. Marks allocation is very important. I think that's where we get things wrong. You see it's 4 marks, you just put a single statement. Okay, they care about marks allocation. That's where UNZA comes in. Question B, define contrapositive. Okay. Again, here I think we resolved that there was some mistake on B. There was some mistake there. Contrapositive. Basically, we are saying P will become Q and Q will become P. Okay. P will become Q. Oh, it's just fine. It's just fine. So if P, then Q. Okay. So you put there P implies Q. Then you say if P, then Q. Then you just put there. By contrapositive, if Q, then P, which implies both must be negated. If they are positive, you have to put the complement there. Okay, if one is positive, put a complement. If one is complemented, remove a complement. So if Q, if not Q, then not P. Okay, so which implies if not Q, then automatically not P there. I hope we are fine. Are we fine so far? Okay, Sally is fine. Okay, everything's fine. Okay, good. So the second question is let A and B be sets. Okay, so expect a question on sets. Let A and B be sets. Then we define the following theory concepts. A, the complement of A. Okay, again, that marks allocation is very, very important. Please quote me right in your exam. First thing first, marks allocation. Okay, basically there are a lot of ways you can answer this question. There are lots of ways. This is not the only way. Okay, this is not the only way. So if you choose to put E as the universal set, okay, then you say, okay, X will be a member of that universal set. Okay, and so on and so forth. The other way, let me share this. Let me share this in the group. Okay, you probably okay, so you just start, well, let E be universal set and be okay, means x is not a member. X is a member of E. Okay, so there are a lot of ways that you can answer this question. Quite a lot of ways. So let's do this. Quite a lot of ways. Okay, so I just shared another way. Okay, I just shared another way. So the other way is saying x basically the same thing. X is not a member of A, but it means X is outside A. Okay, only that we have to overemphasize. Okay, A be a member of that universal set, so it will stand like this. Let me share this in form of a diagram. Okay, so let me just share this in form of a diagram. So that's what we are saying in diagram form. It is coming. Okay, just reached. You can check it out. In diagram form, we are saying X is inside the universal set, but X is not inside A. That's what we are saying. Then A minus B. Well, that's the difference set. I think we have done this quite a number of times. A minus B, we are saying let X be a member of those two, and we know that minus there means and. So we are saying X is a member of A, but X is not a member of B. That's quite important, and those max allocation quite important. Okay, then C, that's cardinality. Okay, so always define some set. So the this is non-empty set, very important. I think in one of the papers that I shared as a solution, we are putting the statements. No, I think we were doing this. We were doing this while at school. We are saying, let A be a non-empty set. It means it has at least some element. So we are saying X is a member of that, and cardinality of this is basically that very X. Power set, same thing. So just raise it to the cardinality. I don't know. I don't know if we are okay up to this point. Are we good up to this point? Otherwise, please unmute yourself. Okay. Erica, are we good? Sally, are we good? Erica? Okay, good. Thank you so much. So question 3 says, please go ahead. Please go ahead. Which question exactly? Padi. Okay, so here was about the cardinality of A. So this speaks to the fact that, remember, cardinality of a set is just the number of elements in that set. I hope we are fine. So for us to define what a cardinality is, the set must be a non-empty set. And if it is a non-empty set, it has X elements. Okay, it has at least an element. So we are just saying we assume X is a member of A, which makes A not an empty set. So I'm talking about cardinality, and it is basically here. So we are saying A is non-empty set. By it being non-empty set, it means it means it has some element there. And cardinality is basically just the number of elements. So we are just saying it's basically that very element. So cardinality of a set, if you can proceed there, you can say modulo A, you close there, equals to be even specific 1, because we only have a single element there. You can say dash A mod there equals 1, to be even more specific. I don't know if I got your question. Okay, thank you. Same as power set. Power set is basically 2 to the power sum, the number of elements there. So again, here we are supposed to say 2 to the power x there, and initially every set must have at least one subset. So a set plus an empty set, and so on and so forth. So we go to question 3. In relation, please go ahead. X there, yes, because that is an element. So that is an honest mistake there. That is even more precise. That's what I was trying to say even here. That's what I was trying to say even here. So because we have just a single element, you can say A is equals to 1. So even here, because we're just using one element, we can just say P in bracket A is equals to 2 to the power 1, which will give us 2 there. Even more precise. I hope we are clear. Okay. Question 3. In relations, define what partial order is. I think we did speak about this lots of times. Partial order. So we are saying A, we let A be a non-empty set, and we let at least 3 elements. Remember, whether equivalent set or partial ordered set, at some point we'll deal with 3 elements. So we say we let x1 z be a member of that A. Okay, a partial order set is the set with the following characteristics or properties. Number 1, I think on that one we can discuss. What are the three characteristics of partial ordered set? Who still remembers those initials, the PE? Erica, do you remember PE? Lisi, Millie, Sally, do we remember the PE?
Yes.
Okay, good. What are the three properties of a partial order? Please go ahead. Okay. Okay. Okay, so remember, you need to answer those mathematically. Okay, so the moment you do this, x comma x is related. What does this tell you? What does that tell you? What property is that? Exactly, that's what I wanted you to say, or that's what we wanted to hear. Okay, so this is property number one. Property number two, we have um, x and y are related, but y and x are not related. What property is that? Millie, what property is that? What property is that? Millie, are you in the group? Or you can't talk? We don't know. Erica, what property is that? Antisymmetric. Thank you. Wherever you say x, there are three guys there. Then x and y are related. Y and a and z are related. By default, x and z are related. What property is that, Sally? Sally, what property is that? Sally, are you in the meeting? I hope you can see that. So x, y, and z are elements or members of that set A. Then x and y are related, y and z are related, then x, z are related. What property is that? What property is that?
Transitive.
Okay. Transitivity. That is very much true. Okay. I hope we are good. Kindly give me a thumbs up. Are we okay? Are we together up to this point? Millie, are we good? Are you in the meeting? We are not. We don't know for sure if she's in the meeting. She's too quiet. Millie, are we in the meeting? Are we in the meeting, Millie? Are we in the meeting? We don't know for sure. She isn't responding, which is quite sad. Give me a minute. I think she seems not to be in the meeting. Okay, we will continue nonetheless. Okay, that is a partial ordered set. Then for illustrate, describe the procedure for transforming a diagram to partial order into transforming a diagram of partial order into Hays diagram. Okay, so we are starting with a diagram of a partial order to Hays, and that's what we are doing. So we have that this is reflexive, then this this to that, this to that, this to that, this is anti-symmetric because we don't have coming back, we don't have coming back, we don't have coming back. That is anti-symmetric. Then we just remove those ears, and the longest path, and that is our Hays diagram. We are good. Okay, Erica, are we good? Sally, Lucy, are we good? Okay, good. Question 4. Describe components of a looping structure. Components of a looping structure. Okay. Basically, we are just giving what is contained in a loop. At least we know that there is initialization, there is a condition, there is body, and there is update. Loop variable are defined. Mama, give me a minute. Mama. Fine. I think fine. All my ironia and Dineka. After my classes, kuma 14. After my classes. Nende pamena bwera. Olo ni meeting up. Mbadde otikyaba bakangosukama mbale mungasibakazi. Okay, thank you for that. So describing a loop construct. So a loop contains contains four stages. Number one, you need to initialize with variables there. Then there must be a condition, okay, for testing part. The body, which is the actual set of instruction to be executed, and it has to be repeated based on the condition, okay. Then the update to increment. This update is the one which makes a loop at some point to terminate. If at all there is no that, then the loop will keep on going and going. That's quite important. That's quite important to establish. The other question is illustrate in flowchart. So this is what we are talking about. So we have initialization of variables. So I is equals to some value, j is equals to some value. Then you can come up with just your own. If I is less than or equal to b, please go ahead, Erica. Okay. 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 That is at grade 12. After university level, they will never teach you that. What is important is you showing the initialization. I think the only the only diagram which is different from all these is a decision box. They don't care about that. So don't panic by saying, okay, it has to be slanted. That is at grade 12. No, this is used for that. This is used for that. In here, we don't really care. Hope I've answered your question. Have I answered your question? Okay, good. So that is initialization, okay, which is this part, initialization. So there are variables that are going to be defined there. Then there's a condition in the decision box. You can come up with anything. Okay, it's you to make that up. So if this is true, then you can assign I plus b, okay, I plus some value there to c. Then you print that. Please, we forgot something here. There is an increment part. You have to increment whatever you so if no, you multiply those, then you print. Otherwise, you have to increment. Incrementing is always after printing. So after printing, you increment. After you increment, then you go back to condition. So it was supposed to be, and what do you increment? You increment what is in the decision box. So you can say after this you say I plus plus, then you get back, okay, I plus plus, then you get back not until this condition become false. Then in fact we you can come up with really anything. I think that's quite important to establish. Please get the concept. Try by all means to come up with your own flow chart if such a question came. Are we good? Can you give me a thumbs up? Are we good? Midi, you're still not in the meeting? Okay. I don't know. I think she left long ago. Just give me a minute. Okay. She's not in the meeting. I think that's what my new phone does. If it goes off, it remains locked. So she's just locked in. Me break. Okay. That's what we are basically saying there. Okay. So the other question is about so there. So the other question is about this, and it's about hence what condition ensures solve the following that okay. So we have this. So wherever a question comes like this, please always know that they want the value of x for which this condition is gonna be true. So focus on the first number and the last number here. Find the GCD of 2. Don't focus here. So 7 and 20. I think we know how to do this. You begin. So 20 comes on the left, 7 comes here, then we divide that, which will become 2 plus the remainder is 6. Then 7 comes here, 6 comes here, 6 into that is 1 plus the remainder 1. Okay, so when the remainder remains 1, you can know that this has the inverse. So if it has the inverse, then you can go and you can basically go and find the solution. I think that's quite important. Okay, then you start. So that's the first equation, that's the second equation. Nonetheless, you have to now make those remainders the subject of the formulas. Okay, so for this equation, the remainder is 1, that is 1 there, equals 7. 7, then pass in 1 here, which is 1. Okay, remember this one is positive, so 6 will just go this side, it will become negative. Throw in 1 there. Okay, and this one as well, 6 is the remainder, makes 6 the subject of the formula, equals, then this 7 will go the other side, which will become negative. Then it has in 2 there. Then always start with the equation, the downmost equation. Okay, which is 1 is equals to 7 in 1 minus 6 in 1. Now look for other equations whose remainder is one of these. So look for 7. Was 7 a remainder? No. Was 6 a remainder? Yes, 6 was a remainder. So 6 is this, which is 20 in 1 minus 7 in 1. So wherever we have 6 here, per 6, we are just substituting this equation wherever there is 6. So 20 in 1 minus 7 in 1 in 2, which is that. But this 6 has 1 there, so it has to come back. 1 there, it has to come back. If this was 3, this would have been 3, this would have been 3. So that you multiply 2 times 1 and 1 times 1, which will give you 1 and 2. Then you open the bracket. This will be negative 20 in 1, then this will be negative positive 7 in 2, and your like terms are 7 and 7, so put them together. According to a sign here, you just add what is in the bracket. So 1 plus 2, which is 3, then minus 20 there. And we remember, you have to come up with this equation. Okay, 7x plus 20y. This is what is in the bracket. So 7x add 20, put y, is equals to the GCD of 7 and 20, and this is what we are doing here. GCD of 7 and 20. You found the GCD of 7 and 20 is 1. Okay. Then compare this equation and the equation you have. So the equation we have 7 in 3 plus 20 in 20 in some value. But remember here, this is negative, so throw this negative in the bracket so that it remains positive, so that you remain with positive. So x here will be basically 3. Okay, you just compare this to 3, but always remember, this value is not here for decoration. Whatever answer you find, multiply it with this value. So that's what we are doing there. So 3 by 3, which is 9. So x is 9. Are we good? Are we good?
A question.
Please go ahead. Yes. Remember, how do we find the GCD? You get the first value and this, which is that. So 27 here, 7 into 20 is 2, plus 6, which is a remainder. 7 become this, 6 become that. 7 into 6 is 1, remainder 1. Okay, you can go on and on if you want to prove that 6 will come this side, 1 will come here, so it will be 6 is equals to 1. So 1 into 6 in bracket will be 6 plus what is the remainder? 0. I hope you can imagine that. Then remember it was 6 is equals to 1, so 1 will become this side, will be equal to, then this side we have plus 0, it will be 1 equals 0. Okay, so whichever number which is here equals 0, that number which is on the leftmost is the GCD. Which can demonstrate this. Let me do this. Let's just send this in the group. 20 is equals to 7, 2 plus 6. 7 is equals to 6 plus 1 plus 1. 6 is equals to 1 plus 6 is 0. Then 1 is equals to 0. So this is GC, greatest common divisor. Okay. Okay. So let me forward this in the group. Please go ahead. Please go ahead. Okay, you can't have GCD negative 1. You really can't. So but you can have the GCD. You can't have a remainder negative. GCD is just a remainder. So I have sent an image in the group. I think you can check it out. What we said was, we said two concepts. We put across two concepts. The concept number 1 is when the GCD is not 1, then the equation doesn't have a solution. So just say, since the GCD is not equal to 1, the equation does not have a solution. That was number 1. Do you remember that?
Oh, yes, that's the concept.
It can be 2, the GCD can be 2, the GCD can be 3, the GCD can be 4, as long as it's not 1. The equation doesn't have a solution. 2. Have you seen Erica? Go in the group. Have you seen what I've sent?
Yes.
Okay. So I beg your pardon. Please go ahead. No. Oh, okay. Yes. Okay. Thank you. So, as long as the GCD is not 1, the equation doesn't have a solution. Please, that is very, very important. So that is why the GCD is 1. That's why we left off at the equation number 2, because we want to get any equation whose remainder is non-zero. The remainder must be non-zero. So the last equation and the second last equation have no effect, because the last equation doesn't add up. The second last equation adds up, but the remainder is 0. And remember, the GCD, we are interested in a remainder. And when the remainder is 0, it means the equation has no remainder. Do you get that concept? Erica, do we get that concept? Are you looking at the image I sent in the group?
Yes.
Okay. So let us start from the very bottom. Does 1 equal to 0 make sense? Let us interact a little.
No.
It doesn't. Good. The second last equation, does it make sense?
Yes.
It does. But the GCD, greatest common divisor, what is our interest? In the greatest common divisor, which is the GCD, what is our interest? With our interest, the GCD is just basically a remainder, not so? Great. So the second last equation, when the remainder is 0, does it mean we have a remainder?
No.
No. So the third last equation, do we have a remainder?
The third last one. No. No.
The third equation from the last,
No.
from the bottom, do we have a remainder?
No.
Are you sure we don't?
Second one is the second one. 6 is equal to 1. 6 plus 0.
From the bottom,
Oh,
we have. And what is our remainder?
1.
Good. That is the reason we left solving at this point. Can you see the screen?
Yes, I can.
You can see the screen?
Yes.
Okay, good. So, if you see, we left this at 7 is equals to 6 in 1 plus 1. We've seen that?
Yes.
So, that's why the GCD is 1 there. But if you if you don't want to get confused, with which one is the GCD, you can go all the way we went, so that whatever number is going to be on the left, then it's equals to 0. That number on the left becomes our GCD. Do we get that now?
Yes, I do.
Good. That's quite important. And whatever value you are going to find here, whatever value you are going to find by substitution, this value here, multiply it with this value there. If here we have 10, then this x would have been 30. If here was 1, then x would have 3 multiplied by that 1. Are we okay with working out that? Are we good? Okay, good. Right. Uh, uh, good. So we want to ensure section A is done, so that tomorrow we look at section B, and Wednesday a different paper, and so on and so forth. So that is what we are saying there. Okay, so we Okay, let me do this. Just give me a minute. Okay, so I think that was the last question on section A. Unless you have a question, tomorrow we work on section B. We get done away with this. Then Wednesday, I think Wednesday we look at 2024. We start with section B. God willing, we can touch section A. Do we have a question? If we don't, kindly give me a thumbs up. Do we have a question? Okay, thank you. Have a blessed evening, and see us tomorrow, or God willing.